The goal of the pivot operator is to allow you to take data that appears in a group by column in an aggregate query and use those data values as column headings in a new query. A pivoting operation involves three distinct processing phases: a grouping phase, a spreading phase, and an aggregation phase. So let's take a look at how you can use this pivot operator. In this sample code, I'm going to use a view that summarizes Northwind sales by customer and by year. So here's the create view statement. It's going to be called customer orders by year. So the select statement returns the company name, as well as the year of the order date and the sum of the subtotal of sales. And I take the information from customers and join on orders, and then join on order subtotals as well. And then I'm going to group by company name and year. All right, so I'll go ahead and create the view and also do a select statement that displays its returns, that displays its results. All right, so there you can see that we have company name and order year, company name, order year, and so forth. And we end up with 234 rows. So the data is going to have multiple rows for each company, one row for each year that they placed an order with Northwind. Okay, so that view is useful, returns some nice information, but say that you want to see each distinct year appear as a column heading, so that each company's sales amount is summarized by year. Because again, at the moment, I have multiple company records, one for each year. So one way to do it is with this kind of statement. This is a standard SQL query which sums the amount column for each order year for each company. All right, so the way this works is, once again, I'm returning company name. So that's going to be the leftmost column. And then I have these multiple sum statements that when the order year is a particular year, then it's going to use that amount in that aggregation. So when it's 1996, it's going to be included in this aggregation, which is included under this 1996 column header. When it's 1997, it'll be summarized in this aggregate and included in that column. And for 1998, it's in this column, and which is called 1998. Now, by the way, numbers are not valid SQL identifiers for columns in a result set, so that's why I have these delimited with square brackets. Okay, and this is a group by statement, so I'm grouping by company name. So when I run this, there are the results. So now I've pivoted the data. I'm not yet using the pivot operator, but I pivoted the data so that I list the company name, each company's results, with a year or a column for each year. And you can see that this company had no sales in 1996 or didn't place any orders with Northwind in 1996, so that data is null, but they did place orders in 1997 and 1998. Okay, so this is a fairly straightforward grouping query, but it has some kind of messy redundant code to calculate the aggregate for each rotated year column. And you'd have to add another sum statement for each column that you wanted to add to the results. So over time, if you wanted to include more years, you would have to modify the code to add a new column in the results right here. Okay, I mentioned that pivoting data involves three operations. So in this particular code, the grouping operation, or the grouping phase, is handled by the group by clause. So that tells SQL Server that you want to group by company name. The spreading phase happens in these multiple case statements. So this is what separates out the results, the amounts for each year, and puts it in the right bucket. And then the aggregation phase is handled through the sum aggregate in this case. So using standard SQL, you have to include each of these phases in your Transact SQL code explicitly. Okay, but you can also use the pivot operator. A query against the view that uses the pivot operator would let you take one of the group by columns and pivot the data into column headings. And that's what this query does. The select clause lists the company name, so we need that to include that in the output results. But then it lists each of the years that we want to include in the results. And then the pivot operator defines how T-SQL should calculate the contents of each cell in those columns. So here it's going to sum the amount. So that's the equivalent of this statement here. And that handles the aggregation phase. The grouping phase is no longer handled by a group by clause. Instead, pivot figures out which column to group on based on what attributes were not used for the spreading or aggregation phases. Okay, so here's the aggregation phase. So I'm using the amount column that's returned from that view. And then it's using the order year for the spreading. And that only leaves the company name. So by default, pivot will group on the company name field. Now, since the pivot operation determines the grouping specification by looking for columns not involved in the spreading or aggregating operations, you'll rarely perform a pivot directly on a table that's likely to have lots of other columns that you don't need. Instead, create a view as I've done here, or use a derived table or some other table-valued object that returns only the columns that are involved in the pivot. Okay, and so once again, to look at the results, there's what we have, company and columns. Now, to simplify writing the query, you can use an asterisk in the select clause. This saves you from specifying the literal column heading values. So this query returns the exact same results as the previous query. What's interesting here is that remember that the underlying view includes company name, order year, and amount columns. But when you use the star, the asterisk, in the select clause, it sees that order year and amount are used in the pivot operation and doesn't include those columns in the output results. So pivot has some intelligence in how it looks at the data that you're pivoting. One thing to note here is that you have to add an alias, which I called P here, but you can use any valid T-SQL identifier. You have to use that in the pivot statement. In addition, you have to enclose the values in the in clause in square brackets. And this is true even if you're working with text values instead of numbers. Contrary to what you might expect, you should not enclose the text values in quotes inside the square brackets. Okay, so here's another example that uses strings. It's specifying different companies that we want to include within the results. So it's basically doing all the same sort of stuff, but is now pivoting using the company name and grouping by the order year, because now order year is the only column that I'm not using from that view. I'm not using it within the pivot statement anywhere. Now another thing to consider is that very often users want null values in pivot query results to appear as zeros instead. And that's useful, for example, if the user wants to create charts based on the results. And so here's the syntax that you can use to accomplish that. Just using the is null, so that if this is a null value for a company for a particular year, it's going to convert it to 0. Now this technique isn't specific to the pivot operator, but because the pivoted columns aren't in the underlying data, the syntax may look just a little bit strange. So I'll go ahead and execute that. And you can see that now instead of a null for 1996 for this company, we have a 0. Same thing down here, and for other results that returned null values. Companies that didn't have sales in a particular year. You can also unpivot data. This isn't an operation that you'll need very often, but it can come in handy when working with data warehouses. Unpivoting is basically the reverse of pivoting data, in that you're rotating the columns into rows. The result is that each row of the source data becomes one or more, potentially many more, rows in the output, one row for each of the specified source column values. It's important to understand, though, that most pivoting operations include aggregations. So unpivoting will not return pivoted data to its original form. You can perform this operation using standard SQL, but it's much easier with the T-SQL unpivot operator. So let's take a look at unpivoting the company sales information that I created earlier. Now, to make the data easier to use, I'm going to start by storing the data in a new company sales table. So I'll use a select into statement that selects the data from that view, pivots it based on the years, and then creates a company sales table and outputs the results of that pivot statement. And then I have a select statement that then displays what's currently in that table. All right, so I'll execute that. And so now we have a table that looks like that pivoted data that we've been working with. All right, now that we have pivoted data saved to the table, say that we want to unpivot the data to generate a result set that has a row with the sales amount for each company and each year of sales. And here's a query that does exactly that. The statement will generate a result set with company name, year, and total amount columns. And it uses the new company sales table that I just created as the source data to be unpivoted. And then the unpivot clause here specifies the column name for the source values. Here I'm using total amount, the name of the output column values, and the list of source column names. Okay? So it's going to output this to the year column, and this is the source data. So this is the columns within company sales that I'm going to use, and that's within an in clause. All right, and then like the pivot operator, you need to specify an alias name. And that gives a name to the table resulting from the unpivot operation, even if you don't use that name within the query itself. Okay, I'll go ahead and execute that, and there's the results. So now if you compare these results to earlier queries that pivoted the data, you can see that this company has two rows because it had sales in 2 years. Remember, it didn't have any sales in 1996. So the unpivoted that data so that now I have 2 rows. But for companies that had sales in all 3 years, I ended up with 3 rows in the result set. And so on throughout the source data. The important thing here is that the unpivot operation didn't return a row if the source data had null sales for a year.